Hello and welcome. We're going to be looking at this area. I know, pretty exciting. Let's maybe throw some blue. Okay, so generally what we're doing is considering the possibility. That's pretty. How is that not teal? Alright, there we go. I don't know why I was doing that, but that this is an ammonite. Might as well just go generally out here. Mind you, this kind of broke apart here. And then cross this way, maybe somewhere over here. Like where exactly, unclear, maybe here. And then across, generally to like this boundary, not into these ones. And then to this boundary. And then something across here. Across this way. Spiraling in, maybe basically out in. So let's just say ... something in this region. Something of this nature. So that's the idea, is that there's currents flowing here that aren't flowing everywhere on the earth. These currents are flowing, this is water flowing atop the earth, possibly freezing as ice that's then shaping the earth below by just the sheer amount of energy flowing in this region. Whether or not it's ice or not, I'm not sure. People just say it's ice because there's glaciers and big boulders, but if there's enough water moving, like I really don't know how people would know it to be ice just because there's ice now. Well, the water froze after it stopped doing this, so it's still not clear to me unequivocally that there are all these glaciers that are said to be in existence. It's possible that they just didn't exist, and were actually just so much water that it looked like glaciers, and we've just interpreted it that way. I don't know. But I was watching Randall Carlson's recent, I think, whatever he did on his YouTube channel last night, that I'm pretty sure is actually going to be a podcast episode. And he brought up this, and it kind of was like, they're not twin impacts. These are not simultaneous. So if these are impacts, according to interpretation, it's very easy to look at these and be like, twin impact, if we just think impacts are like the case always. But they're not. Literally not even simultaneous. This one's 470 million years. This one's 290, or vice versa. I can't remember. Distinctly not simultaneous. Like if we go to Google Scholar, they're called Clearwater Lake impacts. Argon dating of the structures, not the binary asteroid impact, it seems. $470 for the east one, $290 for the west one. They're just not simultaneous whatsoever. There's no overlap. $283, $465. Like, clearly not simultaneous. these things did not form together. If we think impacts, well, all these things are impacts. Everything is an impact that looks circular. Like, then it would make sense to just assume them to be simultaneous, but it's highly anomalous that they're not simultaneous. There's a paper somewhere, scholar, like probability of two adjacent non-simultaneous impact craters or something. Doublet craters. I don't know where the paper is. The low probability of two craters forming close together in space. Maybe this one. Maybe this one. In space and time suggests that doublets were formed by the simultaneous impact of a binary asteroid. Blah, blah, blah. Binary, okay. Maybe not then. There's a paper I've came across where they literally are like analyzing the probability of two adjacent craters like this. And I believe their conclusion is that one can happen per planet. Like, per the amount of time that Earth has existed according to radiometric dating interpretations of modern science, which is not even true. But besides the point, according to that, only one of these coincidences could exist on the entire planet. Is not the only one, though. There's many. There's the Kara twin impacts, which are deemed to not be simultaneous. Also, Donetsk has twin impacts, which I'm not sure completely if they're simultaneous. But like this one is considered a confirmed impact. But we can just look at it for 4 seconds and see it's not. Let me do this. I know we're passing 4 seconds pretty quickly here. Come over hither. Let's paste this. Right, of course we see the impact, if you will, call it an impact here. But like, what's this? We gonna ignore this? Or are we gonna notice that there's an adjacent roundedness that actually continues in the rivers because it's based in rivers that we're seeing it, and then this one goes this way, but we can kind of see it join this way, and then we see this one here which kind of goes across here, and then something that's got a boundary more so like this, and then like this, and then like this, maybe. Like, it almost looks like a flower. Here, maybe. Like, sure, this one's circular, and even it seems to have something maybe there, too. And if you ignore the things I drew around it, you can kind of draw, like, another circle around it and be like, see, it's even bigger than the first circle. But it totally ignores all these features that are way too, like, present in the terrain to ignore. Like, this is a circle just as well as this is. What kind of impact would do this? So anyway, that's why it's important to know that this region was actually experiencing something of this nature, where there's a current flowing that had a backstop over here, that had an endpoint over here. Generally speaking, that was an ammonite shape that was then gouging into the crust of the earth from above, while other features were happening over here below. There was another one going on here. another spiral here somewhere. Something like this. And then that goes across that way down there. Another one here goes across that way. And then there's that current. I guess I should use a different color. A little late on that, but there's a current that like comes down here, swirls in here, comes in through this way and this way as well around this node, and then just creates this region. There's another current of the Columbia River basalt that's interacting with this current. There's things coming through this way as well that are like the hand of God here. Something like that nature. I didn't draw that very well, but point is, there's things going on totally unaccounted for. So obviously when we don't account for things that are going on that happened, then we just don't cover the full details. So, my thought is, whenever there's a eddy, if we go to hither, like this one, but like here, all these that go around the top, the North Pole, that open the North Pole here. There's a bunch of circular features. Here's one, especially. Here's one centered on this, but wider. They're literally everywhere that two currents interact tangentially. So, like, one going this way, another going this way, induces a current that goes like here. So it goes with it, and then like into resistance of this current that's wider than a single path, but like focusedly there. And so it swirls around and it produces something like that. And then probably one over here, like specifically doing things of this nature, where they flow with the currents. So the question is that happening in the terrain? Like, we can for sure see lines generally. So let's take this region right here. Start with this one because I've looked more at it. Let's go like that. For sure, we see lines going, obviously, this way. I really don't know why it's doing that. Weird. Generally going this way. There's definitely lines, possibly the other way, like this way. But generally going across this way, this way, this way. But what we also see is like here we see a line going down this way. We see down this way, down this way, down this. Let's just pull up the map. down here, pretty much cutting across this way. Down here we see here. So there certainly are more than one angle. That's what I'm getting at. More than one angle that these currents are propagating in this region. Look around. Going around. It's almost like this system was provided resistance, like it was swirling. Let's say there's a swirling eddy going on here. That presumably goes with them, so let's say that way. This way. Based on these arrows, and that this goes down maybe. So then it goes across with this one and down with this one, but then it swirls back because of resistance, I guess. But then that would provide basically a relative pressure reduction for this current here. Like this current's coming in, it's coming in, and it hits this resistance. So it preferentially like ends up going around it relatively, but then over here there's this like anti-resistance, like a low pressure zone versus high pressure here. So it has to like find its way around, or I guess high pressure here and here, but high here because of this, and then low here because of this also. So it I'll call you back, Jack. Anyway, let's assume another eddy here. I must have hit something. There we go. Another eddy here. Although possibly this eddy might be like going with this, so this way, like this. I don't know. They're not simultaneous, so it's maybe that one of them formed and then the other formed, and that they're not actually simultaneous ever. Although I'm pretty sure like these eddies were going at some point when they were simultaneous. Oh crap. We can see a line going through there. Like looking down here, I don't see as much cross going this way. Like it's much more uniform. Maybe a little bit of things like this one. Or over here, it's just got these staggering things. Yeah, I don't see it over here as much, if at all. And then this goes this way. We see it go this way, but then over here it goes up this way. Over this way. I've not really tried to follow these that much. Cross this way, cross here. Where basically it runs into this. If we look at this region, it's got this thing like a flame, but then it's got a secondary flame. So it's like this was an inlet. This was a major inlet where this current was flowing this way, and then it came off this way, went around here, and also continued this way. Like anything that went through this channel ended up largely going this way. Some of it, I guess, out maybe, but then across too. Just across, probably drilling into this region, like this current. Like coming in here. Like a flame, but then essentially going across here where it ran into resistance. Also, Randall Carlson talked about this. He pointed it out here to this location. This is at a like phi ratio distance within like A, B, or whatever, like A, B. Which to me basically demonstrates it's not an impact, but it shows a relationship between these. So we definitely have a current coming in this way. Like we can tell it's coming in this way because of the shape. And then it just keeps going. But it also comes this way. So it must be going this way then. It must be going this way. Does that fit what I was saying earlier? Unless it's coming out of the center, like spiraling out of the center. Kind of makes sense if it like is a corkscrew type thing going on. That it would have like a focal point that then it fractally could extend outward further and further in terms of how much it influences. I should get back to Jack. I'll be back. I'll be back. Certainly something up with this in terms of the current flows. I can see unequivocally their presence. Like they're very distinct. We can see shapes enough where if we really look at this, I imagine the structures will pop out better and how they formed, like some of them being more obvious than others. Like clearly a current flowed here, clearly it flowed this way and went out this way, but also went this way and interacted with whatever this like is going on here. Maybe this is related to like a current flowing across this way even. Although Alaska, it confuses everything because of the accretion of new material during the Earth's expansion process, so it just wasn't like that necessarily, like at all. Okay, I'll be back.